Okay, so what's happening in school, firstly?
Are doing spatial identities now.
Special identities, which we have already covered, right? Are you
Yeah.
facing any difficulty in the questions?
No, not really. I haven't faced any difficulty yet. Because right now we just started, not really done that much. So yeah.
Okay, got it. I'll just open your book, just a moment. So we completed fourth one, right? We had to start with the fifth chapter.
Teacher, we also had to do revision exercise 18. I'm not so sure, like the question. I'm not so sure about a few questions there.
Can you tell me the page number?
102.
1021. Yes. In this one, which question?
Question 1, question 4, and 9.
Okay, let's start with question number 1.
And 5B, I've done it. So yeah, I can tell you the answer for 5B.
5B.
Yes.
Okay. Let's discuss it one by one. Let's start from the first one. I think we discussed the first one, Bhavin. Remember, I told you we have two linear equations, and linear equation gives us two straight lines on the graph, right?
Yeah.
One linear equation, one straight line. So here we have two. Now, we have their point of intersection, which is?
It's an 2 negative 3.
Yes.
Yeah.
So we will put these values as x and y in both the equations. Let's put it in the first one. What will you get?
Oh, yeah. I think I've done this before.
Yes. Give it a try if you forgot. Yeah.
First equation would be 2p plus 2p minus 3 equals 3. And second equation would be 2 minus 6 equals q.
Q. So you will get the values of P and Q, and then whatever they are asking, you can find it out, right?
Yeah.
Or they're asking just P and Q only.
Yeah, just asking P and Q.
Okay, I think fourth one was something which we need to discuss. Let's do it in the end. Yeah. Let's do firstly ninth one. I think I skipped.
Ninth, I'm not so sure to do it.
Okay. In question number 9, the diagram shows a trapezium ABCD. Okay, so trapezium is a figure which has one pair of parallel sides, right? And one pair of non-parallel sides. Here we have one as 3x, another parallel side is 5x plus 6 centimeter. Given that the perpendicular distance between AB and DC, which is nothing but a height, is 4x minus 3, show that the area of trapezium can be expressed as this. So area of trapezium is what?
Area of trapezium is so both the sides, the parallel sides added together times the perpendicular line,
Which is height.
width. Yeah,
and divide by 2. Yeah, put the values and then we will discuss. Okay.
Okay.
Just a minute.
16x square minus 9 cm.
You're getting the same expression?
Yeah, yeah.
Okay, yes, 16x square minus 9 centimeters square. Let's move to the next one,
Yeah.
fourth one.
Okay.
So in question number 4, they're talking about 4 things, Bhavan. One is number of students, which includes boys and girls, right?
Yeah.
And then we have apples and oranges, which are distributed among them.
Yeah.
So one boy, so we have B plus G equal to 35, right? There are 35 students in a class.
Yeah.
Each boy is given, let's say one boy is given 2 apples and 1 orange, right?
Yeah.
So let's say there are X boys. So can we say 2x plus X will be total quantity they are getting? 2x plus 1x.
Yeah.
These are number of apples to those boys and these are number of oranges to those boys.
Yeah.
And similarly, let's say girls are Y. You can even take it as B and G, that is your choice. It is given that each girl is given 2 oranges and an apple. That means 1Y plus 2Y. Right? This is for oranges. This is for apples. Now, can we say 2x plus 1y? Apples. These were the apples quantities. 2x plus 1y.
Yes.
Should be less than 60. It is given in the question.
Yeah.
Also, we need to find x plus 2y is minimum how much, which is your question, and which is number of oranges, right? We need to find the minimum value of this one. And
Yeah.
x plus y is given as 35. X is boys and y is girls. Right? So can we take x as 35 minus y
Yeah.
and put it here?
Yeah. So from here you can do that. Yeah.
Yes.
Simultaneous equation.
Right. So if we put it here, we'll get 70 minus 2y plus y less than 60. 70 minus y less than 60. 10 is less than y, or we can say y is greater than 10. Just have a look till here.
Yeah.
And if y is greater than 10, x has to be, let's say if it's 11. So 35 minus 11 will give us 24, right? So x can be 24, 23, 22, anything. So if y is, what maximum we can take y is 35, then x would be 0. Can we say that?
Yeah.
So what would be the range of x?
X would be from X would be 12.
12?
12 to, yeah.
Can it
X
be
can be anything from 12 to 0.
12 to 0? But I can put y as this. If I put y as 11, I'm getting x as 24.
Wait, sorry.
If I'm putting y as 11, because y is greater than 10, right?
Yeah.
So I'm getting x as 24. 35 minus 11. Isn't it?
Isn't that 2x? Oh, x plus y is 30. Okay. Yeah.
Yes. I'm solving this one. Then we will come to this expression.
Okay. Yeah. So it will be anything from 24 to 0.
24 to
0.
I think we should take it as 1 because, but it is less than 60. Yeah, anything can be the case. Okay, if we are taking 24 to 0, then how can we find the minimum of this x plus 2y? That were oranges.
Minimum number of oranges.
I think there is one confusion here whether to take 0 or not. Because if we are taking 1 and y we are taking 11. So it will be 23. Can you please check in the answer key, Bhavin? If they're taking 0 or not, like what's the final answer they are getting?
Okay. Question 4. 4 is 46.
46 they are saying.
Yeah.
But if we are taking y as minimum, they want minimum or maximum? Find the minimum number of oranges that were distributed. Minimum number of oranges. So x plus 2y. So we need to minimize both of them. So if I have to solve this one, and if I know that x plus y is 35, so let's put x is equal to 35 minus y in this. So we'll get 35 minus y plus 2y, which will give me 35 plus y. So anything greater than 35, and y is coming out 11. Yeah. 46, no? Or 43?
46.
46, yeah. So they're solving it this way. We have taken the minimum value of y here. See, these were number of oranges, correct? X plus 2y. Should we do it again? Bhavan, can you hear me? Bhavin, you are freezed. Bhavin, am I audible? Bhavin, you are on mute.
Teacher, is it working? Was my internet still broken?
What?
Am I audible now?
Yes, you are. You are now. What happened?
Oh, okay. No, I don't know for some reason. I'm trying to fix my internet.
Okay, so let's do question number 4 one more time. We have this x plus y as 35, where x are number of boys and y are number of girls. Okay.
Yeah.
And for apples, we got this equation. Is this clear? Okay, now we solved first and second. We substituted
Wait,
x as.
wait, no, wait. I got it. Yeah.
Do you want to give it a try?
No, I don't understand the part after. Like, I
Okay,
don't
so
understand how is X from,
as in how do we get the final answer? That one?
yeah,
Okay, so have you got that y is greater than 10?
yeah,
Okay, now we need to find for minimum number of oranges, which is x plus 2y, correct?
yeah.
Can we use first and third again? And I'm substituting x as 35 minus y.
Wait, X.
Same thing.
Okay, wait. How is that 2y there? Wait,
35.
35 minus all the
I'm not getting what exactly is your doubt. See, the way we have substituted value of x here, similarly, we have substituted it here.
yeah, but I don't get the part where you wrote 35 minus y plus 2y. I don't understand
just,
the 2y part.
it was already there. Oh, as in how I formed the equation.
Yeah,
These are number of oranges, Bhavan. It is given that one boy is getting one orange and one girl is getting 2 oranges.
yeah.
The way we formed this, similarly, we formed this.
So it's 35 minus all the girls plus
Is x, right? Yeah.
Yeah, 35 minus all the girls, which is all the boys plus 2y. Yeah, okay, got that part.
Then we got 35 plus y. Question was, these were number of oranges. Question was to find minimum number of oranges. We have y as greater than 10. So the minimum value y can take is 11.
Yes.
So we just substituted 11 and we got.
Yeah. Okay.
That's all. So that's minimum.
Okay. Got it.
Okay. Now fifth B, I think you have done.
Yeah.
Okay. Any other doubt from this exercise which you want to discuss?
No. No, I don't think there are any doubts.
What?
I don't think I have any doubts.
Okay. Let's move to chapter 5 then.
Yeah.
I think we started with chapter 5, no?
Yes, last week. No, last week we didn't do chapter 5.
No. Before your exam, we did that. Remember, we did this splitting the middle term. We did the factorization.
The middle term into...
Yes. Now we are doing the solving of it. Okay. Solving of quadratic equation. Let's see how to do that.
Okay.
Before solving, we will discuss one question where we can apply splitting so that you will, it will get revised and then we will move to solving it. For example, if we have this x squared plus 10x plus 16, how will you split it into, split the middle term and make the factors out of it?
So we'll do 16x squared. So x squared plus 8x will be one part and 2x plus 16 will be the other part.
Perfect. So you remember that. Now?
Yeah, now you factorize both of them and then can just combine. So I will be, for first one will be x, and second one it will be 2 times x plus 8.
Then?
X plus bracket X plus 2 times bracket X plus 8.
Perfect. So this was factorization of quadratic expression. Now we have quadratic equation. And Bhavin, when we say quadratic equation, it means something is equal to, right?
Yeah.
So now whatever we are taking is equal to 0 here, right? That means we need to solve it now. And when we say solve, we need to get the value of x. So when we say two numbers have their product as 0, that means either one of them has to be 0.
Yeah.
Can we say that?
Wait,
For
I'm
example,
not
if I say A into B is 0, how can their product become 0 if none of them would be 0? So that means 1 has to be 0. I can take any integer except 0, but I will never get 0 back. Yes, Bhavin?
Oh yeah, okay, yeah. Got it.
Okay, now what we will get from here as x?
As X, we can get X, X times X.
Just solve x. This is solving the linear equation.
Wait, which two are the linear equations?
This one
Yeah.
and this one. Just get the values of x from here.
So, wait, I don't get it. Why are both of them 0?
No, we are saying or. Either one of them is 0.
Oh, okay.
Right?
So, yeah. So that the 6 equals if we cancel out the x,
No, you
then
have to
won't
solve it independently. Let's solve this. What will you get as x?
minus 2.
That's all.
Yeah. Oh, minus 8.
That's your answer. Either x is minus 2 or minus 8. That will be, these are the solution of the equation.
Wow, 1 minute.
Yeah.
So I'm back. Yeah, sorry.
Okay, come to page number 109 quickly. There's one green box in middle of that page which says zero product principle. I want you to read it and then we will discuss.
Okay.
Exactly in the middle of the page, zero product principle in the green box.
Yeah. Done.
What they're saying, when we have two numbers or factors which have their product as 0, so either one of them is 0 or both of them can be 0, right?
Yeah.
So we are taking those cases only. Nothing different, nothing else, right?
Yeah.
Okay. Now, whatever we are going to do, firstly, we will make the factors of the quadratic equation either by splitting or directly. For example, if you have something like this, no need to split. No need to split the middle term. What can we do here?
We know that x is 0.
No. Firstly, we will convert it into like these, no, factors. How can we convert it into factors without splitting? Can we take x common?
Yeah.
What we will get?
X times x plus 4.
Yes. So either out of these, what two would be the solutions? Either
X is 0 or 4 is 0.
or x plus 4 is 0. See, either
Oh, yeah.
x is 0 or x plus 4 is 0. You have to just separate the brackets, nothing else, okay?
Okay.
So this is already simplified, no need to solve it further, but this we can simplify. What will it become?
This x equals -4.
That's all.
Okay.
Yeah, so these are the two answers. So here we are not applying splitting, but we had a quadratic equation. We just took common and then made factors and then solved it.
Yeah. Okay.
Please ask if you have any questions, Bhavin.
I don't think I have any questions, but teacher, what's the point of this? Like,
See, what we have learned in the previous part is about factorization, right? How to make factors. So now we are looking for that two answers. When I say two, what I mean here, quadratic always gives you two answers. Linear always gives you one answer. When I say answer, that is value of x, right? So that value of x we are looking for, when we put it back in the equation, we get equal to right hand side. For example, the question we just solved, what was it? X squared plus 10x.
4x.
10x plus 16. Sorry, the question before that, right?
Oh.
Yeah. So we got x as -8 and -2, right? Now, take just left-hand side of this equation and put x as -8. Wherever we had wherever we had x, I substituted it as -8. So square of -8 is 64. 10 into -8 is -80 plus 16. 64 minus 18 is -16 is 0. So that means this number satisfies the given equation, or we can say solution of equation, the way we were solving the linear equation. Let's say x plus 5 is equal to 8. You solve it and take x is equal to 3, right?
Yeah.
And when you put it back in the left hand side, it will come equal to right hand side.
Yeah.
Same thing we are doing in quadratic. We are making the factors, we are getting the value of x. If we put, no need to put it back. This is just for your understanding. If we put it back, it will come equal to right hand side only.
Okay.
Similarly, if I put -2, then again it would be equal to right hand side. Other than these two numbers, Bhavin, there is no other number which can give us 0 on the right hand side. Sorry, left hand side.
Yeah.
Got it? So that's why they are known as solution of the equation. Yes, now tell me.
Okay. Will this only work if the quadratic equation equals to 0?
Yes, if it is not 0, make it 0 by taking everything on the left side. For example, we have x square plus 5x equal to 3. For example, this is just random example.
Plus 5x minus 3.
Yes, convert it into general form and then make it equal to 0.
Okay.
Remember the general form we discussed earlier when we were doing factorization, ax square plus bx plus c. And when we have an equation, we just equate it to 0. That's all. Because we are taking all the constants on the left side only. So nothing is there on the right side except 0.
Okay.
Any other doubt?
No, I think that's it.
Okay. See, if you are confused whether your answer is correct or not, you can do this substitution and check whether it is coming out equal to right side or not. Right?
Yeah.
Okay. Come to page number 110. Again, there is a green box on the top. Not exactly top. Yeah, on the left side. Can you see that? Practice now 1.
Yeah.
Okay. Let's do one question from here, which is question number D part of it. Give it a try.
Okay. Yeah, done.
Let's discuss. What's the answer?
Wait. The answer is both the different values for x, right?
Yes.
Okay. So my first answer is x equals 0, and my second one is x equals 7.5.
7.5.
Yes.
Okay, I'm doing it over here. You can match it up. So if I take x common, I'll
Okay.
get minus 2 by 3x plus 5 equal to 0. Either
Yes.
x is 0 or minus 2 by 3x equal to minus 5, or x equal to minus gets cancelled.
Yeah.
15 over 2, which is 7.5. Perfect. Okay, above, and just one more thing. You can get one answer, but that would be two equal answer. In a way, you can get something like this also. X is equal to 2 and 2. That means in quadratic, you always get two answers, but those two answers can be equal also and they can be unequal also, like in the second example, right? Yeah, so you should not worry when you are getting different answers, right? Sorry, same answers. Different, though it's
Okay.
fine.
Yeah. Okay.
Okay, moving to page number 111. On the top of it, there is practice now 2.
Yeah.
Okay, question number 1, D part. And question number 3. Start doing.
Teacher, how do you do it with like three different terms in the equation? Because
In
like
D
right
part.
now, like yeah, 1D.
Okay, so you can, so as you can see, there's a fraction, right? So get rid of that fraction by taking LCM of the whole expression on the left side. You can take 2
Wait,
here.
yeah.
What we will get in the numerator?
Wait, one. Okay, got it. 3z square minus 10z plus 8.
Perfect. Now can we take 2 over there? 2 gets multiplied and becomes 0
Yeah,
only.
still 0. Yeah.
Is it solvable now using splitting or anything? For now it is splitting only, right?
Oh, okay. Yeah.
Yeah,
Got it.
use splitting and get the values of z.
Okay.
Give me a moment, I'll be back, okay? Just try these 2 questions.
Okay.
Like half an hour break from 5 to 5:30.
Disha, I'm not so sure about question 3.
Question number 3, right?
Yeah, I'm not so sure.
If x is minus 2 is a solution of the equation, find the value of p. Now it's reverse. That means they have already given you the value of x.
Yeah.
And you have to just put it back in the equation and get the value of the missing, whatever is unknown, right? That's p.
Yeah.
So have you done the A part?
I don't know how to do it.
Okay,
The A
let's
part.
take let's take the equation. You know, x is minus 2. One of the solution is given. There are two solutions you know of quadratic.
Yeah.
One is given, right? So if I put here x as minus
So do you
2,
substitute?
what?
We are supposed to substitute.
Yeah, because it's a solution,
Okay.
no? That means it will satisfy the given equation.
4 minus 2 plus.
So we'll get p as 6, right?
Yes.
12 divided by 2. Now, can we write? So this is our first part. In second
Then
part,
we are
they want
supposed-
us. Yeah, tell me.
Are we supposed to substitute it again and then split it?
Yes.
No. Okay.
You can put the value of p in place.
Yeah.
Sorry, up. Yeah, here, and you will get one normal equation the way you know how to solve it, right? You can just
Yes.
split and get the value of x.
Okay. The other answer is x equals negative 4.
Other answer is
X equals negative 4.
negative 4. Perfect. So you got your both the answers. And what about that one? The previous question, 1D.
Yeah. So my answer is z equals 0 and 2.
For this one,
Yeah. Wait.
how?
Yeah, this one.
Can you tell me how did you make the factors?
Yeah. So 8 times 8 times 3 is 24. So 24 factors is I did. 1 moment. Yeah. I think I found where I messed up. Wait, I think so. 1 moment. Wait, never mind. Actually, so my factors are negative 6z and 4z.
Negative 6z and
4z.
plus 4z or minus 4z? Like
Plus.
negative.
Plus, positive.
Are you sure?
Yeah.
Let's give it a try. Let's try it over here. 1 moment. We have 3z square minus 10z plus 6.
It's negative. Yeah, because the negative number times the minus negative number is, yeah.
So we can say it as minus 6z minus 4z, because minus 6 into minus 4 will give us 24, right?
Yeah.
Now the factors would be
3z times z minus 2 and mm, wait, minus 4 z minus 2.
perfect. And
Yeah. 3z minus 4 and z minus 2, which should be 3z minus. Wait, for first one, wait, how do you do 3z minus 4?
you told me.
What?
You only told me 3z minus 4. 3z from here and minus 4 from here, no?
Yeah, I know, but like, how do we like find
Solve it.
z from there? Wait, that's it. Like, okay, so divide by 3, so z equals 1.25. 1.
You can simply write it as 4 by 3 for now, or 1.333 approximately.
Yeah.
And another value of z is?
Another value of z is yeah, 2.
Got it. You can leave in fraction, you can write it in decimal, that is your choice, but both of them are correct, okay?
Okay.
One moment. Okay, let's move to the next part now, which is, okay, now this is something different. Let's firstly discuss it. So let's say, Bhavin, we have a question. Solve 25x square minus 9 equal to 0. Okay, let's start with this one. How will you solve such type of equations? How will you factorize it?
So for second, we can square it, right? Square root.
Yes.
So it would be 5x minus 3.
Perfect. 5x whole square and minus 3 whole square, right?
Yeah.
Now,
Yeah. But what's the point of square rooting since?
can we factorize it now? Remember this identity, special identity?
Yeah. A minus b times a plus b.
So we have a as what?
Oh. So a would be 5x. So 5x minus 3 times 5x plus 3.
That's all. Now, the question is not about just
Yeah.
factorizing. We need to solve it further.
Yeah. So first one would be minus 3 divided by 5x. I mean, x equals minus 3 divided by 5.
For this one?
Minus 0.6. Yeah, minus 0.6. No,
Are you
yeah,
sure?
negative 0.6.
But if we already have negative here, don't we add 3? That side.
Oh, so positive 0.6.
Yes. And here we have negative 0.6, right?
Yeah.
This plus 3 will be taken there, will become minus 3, right? Negative 3.
Yeah. Yeah.
Okay, try this one.
Okay. My x is 3.5 and negative 3.5.
From here,
Yeah.
like this?
Yeah.
Perfect. Very good. Okay, let's
3
move
by
to one more type of question now. So this was another type where we do not have any term with x. Okay.
Yeah. Okay.
Okay, now let's do this one.
Isn't it the same thing?
No, we have plus in between.
Oh, okay. X is 0.6. Negative 0.6
Can you
only.
tell me how?
So we'll square root both of them, which would be, and after using the spatial identity, it would be 5x plus 5x plus 3 times 5x plus 3.
But we do not
And,
have any identity which is a square plus b square. I told you, right? We have a plus b whole square. We have a minus b whole square, but there is no identity which break a plus b whole, a square plus b square. We have these three, right?
oh, yeah.
So that means this cannot be factorized. Even if I try to solve it like we solve the linear equation, I can take 9 over there. It will become minus 9. I can write it as minus 9 by 25.
Yes.
I can write it as x equal to under the root minus 9 by 25 plus minus, because two answers.
Yeah.
But we have negative inside the root. That means we are not going to get real.
Wait, why is it plus minus?
Because we always get, when we solve, okay, I'll just explain this to you before moving further. We know that plus 2, square of plus 2 is also plus 4, and square of minus 2 is also plus 4, right? So that's why whenever we have quadratic, Bhavin, we know that there can be two possible answers. That's why we apply plus and minus in front of the root like this. One is positive, another is negative. Got it? Think of it, yes.
Not really.
We will be discussing about it, don't worry. For now, the main point is that inside the root we have a negative number. We don't know how to solve it. We have done how to solve square root of 4, square root of 2, even though it's in decimal, but we haven't done anything in which we have negative inside the root. So it is no real solution. We cannot solve it.
Is it because for real number, any one of the any one of the factors can be a negative?
As in, can you please repeat that?
Like, is it because like minus 9 over 25 square root, the two factors, any of them can be a negative? Like,
yes, they can't be negative. That's why they are not real, right? Correct. We never get a square as a negative of, sorry, we cannot have square as negative number. We always get a positive number, right?
Yeah.
Just try this one now. 4x square plus 49. I'll be back.
Okay.
thing that we did?
Yeah. Yeah.
Can we say this also has no real solution?
As a what? Yeah. I'm still doing it.
You can also explain it one more way. You can give it a try and then we will discuss the second method.
Okay. Teacher, I'm not so sure what to do after I got 2x square plus 7 square.
Yeah, we cannot do it. No, that's what I'm trying to say. So we have this. Okay, let's discuss both the methods. 1 minute. I'm not able to draw a line here. Okay, first one. Taking 49 to the right side, it will become minus 49. X square will become minus 49 by 4. And x will become under the root minus 49 by 4. Cannot be solved.
Yeah.
If we are not getting
Okay.
any, so it can be solved if I talk about higher grades, Bhavin, but for now, when we say cannot be solved, that means we are not getting any real answer. We are not getting any real solution. So no real solution here. Also, the another way to write it.
What do you mean by what do you mean by not real answer?
Okay, so when we say not real, that means imaginary. What is imaginary? Those numbers, Bhavin, which cannot be represented on a number line. I can represent 0, as in I can represent integers. I can represent negative numbers here. I can represent fractions here.
Yeah.
I can even represent root 2, root 5. But I cannot represent root minus 2, something with negative and the root. So such numbers are imaginary numbers. You will be studying it in maybe next grade. Just small part of it. Obviously, there is a whole different branch of mathematics on imaginary numbers. But during our school time, we just study the basics of it, not that much in detail.
Yes. So like only the negative square root numbers are
Yes.
imaginary or
Yes.
any other.
We can have this. This is real. We can have even this negative outside the root, but we can't have this. Okay. There is one more way to get it. See, if I'm taking 49 to that side, it will become 4x square equal to minus 49, correct?
Yes. Oh,
can we say
so like
4 is a positive number?
4, yeah.
Can we say x square, whatever x is a positive number? Because I told you one thing, that square of any number is positive.
Is positive, yeah.
Yeah. So if whole left-hand side is positive, so how it can be equal to something negative, which is right-hand side? It can't be, right?
Yeah.
So that's why no real solution. This is another explanation of it. You can explain it in both the ways. Maybe in school you will do this thing. This is more, easier to understand. But the base is this.
Okay. So
Got
like,
it?
because is it because whenever we square root a negative number, there are going to be two numbers. One of them is going to be negative, one of them is going to be positive. Well, that is not possible. Both of them must be the same.
Yes, we can say that.
Okay.
So we can simply write this equation has no real solution. Let's try a few questions of such cases.
Okay.
Okay, I'll give you directly only. It's from your book only. 16x square plus 49 equal to 0. I think now it's pretty easy to, do it.
Okay.
Give it a try.
Yeah. Yeah. X equals to minus 49 over 16 square root.
Yes. You can do it with both the methods, Bhavin, but maybe in your school, this method would be followed, right? So make sure you
Yeah.
should know both of them, right? So whatever they follow, you can go with that.
Yeah.
Any questions still here?
No.
Okay, let's move to next part. It was page number, which one?
Right now, I think I page 111.
111?
Yes. Yeah.
Okay, so we discussed what we had in 112. Yes. Next, we have application of quadratic equation in mathematical problem. So remember, even in linear, what we did, after solving, we applied, we had a word problem, we converted into an equation and then we solved it. Similar thing we are going to apply in quadratic, right? But this time it's going to be x square, not just x, right? So what exactly I'm trying to say here, let's say, Bhavin, listen to me very carefully. Two consecutive odd numbers, positive odd numbers, are such that the sum of their squares is 130. Find two numbers. Okay, so we do not have direct equations, we have something which we can use and form the equation, right?
So basically, it is one x x square plus x plus 1 square.
Why plus 1? When we say odd number,
Okay.
for example 1 and 3, these two are
I'm trying to
consecutive odd
plus
numbers.
2. Yeah, plus 2. Yeah, plus 2. So x square plus 4
X plus
equals
2
130.
whole square, right? This is our number and we squared it up.
Yeah.
This is equal to 130. Open the brackets, solve it, you will get a
Yeah.
quadratic.
Okay. 2x square plus 4x plus 4 equals 130. So
Can you tell me what will it be?
x. No, after simplifying that, I got 2x square plus 4x plus 4
4x plus 4. Perfect.
equals
Equal to 130. You can take 130 to the left and then solve it.
okay. I'm not really sure that if there are any two factors of negative 252 that
2x
is
square plus 4x minus 126 equal to 0, right?
yeah.
So you can take 2 common from here and it will be x square plus 2x minus 63 equal to 0. Taking 2 common and taking to the right side will give you 0, right?
Wait, I don't understand how we got 2 and 63 because like aren't they supposed to add up to 4?
I have taken 2 common from the whole equation
Yeah.
and then took 2 to the right side. 0 divided by 2 is 0 only.
Yeah.
That's all. Okay. It's just, see, you can solve it here also, but point is it will become easier for you now. Right?
Yeah.
Okay. Now 63.
Wait, but, teacher, is it even possible to solve it on the
Yes, it is.
upper one?
Yes, it is. See,
How do we do it?
x square plus 2x minus 63 equal to 0.
Yeah.
And then we can just, we know 63 is 7 into 9.
Yes.
And the difference between them is 2. So use it.
Wait. Okay. So x square plus 9x and
Minus.
minus 7x minus
Very
63.
nice. Yes.
Okay.
Now,
But teacher, like for the without like dividing the equation by 2, how do we like solve that one?
it will be,
Like,
it is solvable. It is solvable, Bhavin. It's just that you will multiply 2 into 126, right? That will give you 252.
Yes.
Now you can just do the prime factorization of 252, which will be 126. Then 2 is 63. Then 3 is 21. Right? And then 3 is 7. Right? We can take 18 and 14. That will give us our answer. The difference is 14 and the product is 126. Plus minus you can take care of.
I don't understand the 18 and 14 part.
See, it's hit and trial, we say. I prime factorized it, right?
Yeah.
Sorry, it was 252, no? Now, from here, it will be 3, 21, 3, 7, 7, and 1. Now, I have to think of those two numbers, Bhavin, which will give me difference as 4 and product as 252, right?
Yeah.
So now, what I have done, 2 into 2 is 4, 4 into 3 is 12. I've taken one as 12, another as 21. Difference is not 4, so this is not the correct one, right? So that's how I tried different, this numbers. 2 into 2 is 4. Then I did 4 into, you can try 4 into 7, 28. 9. Is it fine now? Only this one is perfect. Yeah. Only 18 and 14 will satisfy the both of these equations. Both of these conditions, sorry.
Okay.
Yeah, that's how we do it. But it's better to take 2 common because it will definitely make your working easier.
Okay. Yeah.
Solve it and get the values of x.
Teacher, what was your question?
Question was to find two consecutive. This is your question from this book only. Wait, I'll tell you. Page number 113, the top one. Worked example
Okay.
5.
Yeah,
Read it
got
and
it.
go through it. Yeah.
Yeah, got it.
Okay, so this is how we form the quadratic equation and then we solve it to get the answer, right? To get the values of
Yeah.
x from there. Uh, okay, let's try one question. As you can see, we have practiced now 5. We can do question number 2, which is a little different from what we have just discussed.
Okay.
Give it a try. Is it done?
Almost.
Okay. You did thumbs up, no? That's why.
I did.
Now it's gone.
I think. Yeah, I think
It's
I know
okay.
why,
It's okay.
because
Go ahead. Yeah.
I was lifting my hand like this, and then it detected it as thumbs up.
No issues.
Um, Wait, never mind. That's right.
What happened?
No, I'm not really sure. Like, I came into the same problem as before. Uh, I'm not really sure how to factorize it. So, but I think I'll try.
Okay.
Teacher, I'm not really sure how to factorize it.
Are you getting these two equations? X minus y. I have taken two numbers as, you know, the difference is 5 and the sum, square of sum is 169. Can we take that?
Yeah.
Can we write x as 5 plus y
5.
from the first one, taking y to the right side?
Y is the, okay, x minus. Oh, I think I did a different method.
You did it in a different way?
Yeah.
Can you tell me how?
Yeah, so my equation is x square plus x plus 5 whole square.
But they're not saying each square. They're saying sum of their squares, not squares of their sum. There's a difference, no? In the previous question, it was sum of their squares. If you will read it above. Yeah. Here it is square of their sum. So whatever sum we get, x plus y, we need to square that. So you are doing it right. You are doing it right. Just put x plus 5 in the whole square like this.
Yeah.
Equal to 169.
Yeah.
Okay. So let's do one thing. You can solve it and we will be starting from, this is page number what? 113, right? I'll just write it down on the chat box. Yeah. Page 13, question 2. So we'll start from here only in the next session, right?
Okay.
Yeah. Till then, just revise what we have done and try questions from 5A. We have almost completed it. It's just that we need to, you know, practice some of the questions and then we'll be done with it.
Okay. Yeah.
Do you have any doubt, any questions?
No, I don't think so.
That's all. Okay, then I'll see you in the next session. Bye-bye.
Okay, bye.